Welcome everybody. In this video, we are going to go over how can we multiply polynomials. Do something like this, okay? Now for this, in order for us to do this, we need to review a couple of things. First of all, it has to be clear to us what is going to be the difference between us adding and multiplying, okay? So, when we say that we're gonna add x plus x, this is going to have an answer of 2x. Because they are like terms, so remember, there's an invisible 1 here, an invisible 1 here. So you add the numbers and you just keep the same variable, same exponent, which is very different when we multiply. So here we're multiplying x times x. Since we are multiplying, we are going to utilize the law of exponents. The law of exponents says that in multiplication, we add exponents. And here we have invisible ones for both of them, which tells me that my answer is going to be x, and the exponent is going to be 1 plus 1, which is x to the second power. We need to understand the difference between adding x's and multiplying x's. Okay, now let's look at this right here. We have x squared plus x. In order for us to do this, we need to have like terms, same variable, same exponent. Here, we have the same variable, we have different exponents, so we cannot add them. So this will remain exactly the same, x to the second power plus x, which is entirely different from doing x to the second power times x. Here, again, we're going to use our law of exponents because it's multiplication. Do not forget, there's an invisible 1 right here. Okay, so you're going to add exponents. That's going to give you x to the 2 plus 1, third power. Let's do that a little bit better. Third power. Okay. Very good. Now, what happens if I have coefficients? Can I add 2x plus 3x? Well, these are like terms. They have the same variable, same exponents. So all that you're going to do is add the big numbers. 2 plus 3, 5. And we keep the same variable with the same exponent. So 2x plus 3x equals 5x, which will be completely different than multiplying this. Because in multiplication, first, we're going to multiply the big numbers. 2 and 3, that multiplies into a 6. Don't forget, now we're going to multiply the variables. And we're going to add exponents. There's an invisible 1 here, an invisible 1 here. So that is going to give me x times x is going to be x to the second power. Okay? This is basic for us to be able to make this type of multiplication. So we're going to do this two different ways. We're going to start with the box method right here. Okay? So what is the box method about? Well, first of all, it involves a box. So we're going to draw our box. Now I want you to understand that our box is going to have 2 sections on the length and 2 sections on the width. Why? Because we have 2 terms on each one of those parentheses. So on the first thing that we need to remember is that every time that we have these ones, what is inside of the parentheses has to stay together on the same side of the box. Meaning, this is what I mean. The 8x is going to be here. The negative 1 is going to be here. So if they're together in the parentheses, they're together on the same side. Doesn't matter which side, I pick them to be here, they could be up here, but they have to be together. Okay, now, what about the other ones? So let's see. 4x plus 3. They are together, so they stay together on the same side. Okay? After this, all that we're going to do is we're going to start multiplying. Multiplying to fill what is inside of each one of these boxes. So we're pretty much doing like length times width. Okay? So we're going to multiply 8x times 4x. So in multiplication, we multiply the big numbers. 4 times 8 is going to give us a 32. And then x times x, x to the second power. Now we're going to move on to this box. How am I going to fill this box? Doing length times width. So 8x times 3. So 8 times 3, 24. And we have x times nothing stays an x. Okay? Now, what about this box? Negative 1 times 4x. So negative times a positive, negative, 1 times 4, 4, and x times nothing remains an x. At last, probably the easiest multiplication, negative 1 times 3. That's going to give me negative 3. So each one of these boxes is an individual multiplication. Now we're going to put them all together. 32x to the second power plus, because the 24 is positive, so plus 24x, because the 24 was positive always. Next, we have negative 4x, so we're going to write it right here, negative 4x. And then at last, we have our negative 3 right here, negative 3. Okay, so now, the only thing that we have to do is look for like terms. In this case, I can notice right away those two are like, okay? So we're going to be able to combine them. Okay, so how is this going to look at the end? The 32x to the second power is not going to change, so it's going to stay 32x to the second power. And it's the highest exponent, so it always goes first. Then we're going to go with the x's. So we have 24x minus 4x, that's going to give me positive 20x. And then at last we have the minus 3, because nothing is going to happen to it. At this point, guys, we are done multiplying, and there's no more like terms for us to combine. So this is my final answer. Very good. Now let's look at the next example. Okay, this example might look a little bit different to you because you are used to seeing double parentheses. Do not forget, when you see this to the second power, that actually means that you have p minus 5 times p minus 5. It's to the second power, so it's multiplying twice itself, okay? So now, I'm not going to use the box method here. I'm going to use what many of you call the arrow method. What does that mean? For us to be able to make this multiplication, each one of the members of the first parentheses have to multiply the second one. Like this. P times P, that's going to be P to the second power. But also, P is also going to multiply the negative 5 on the second parentheses. So P minus times negative 5 is going to be negative 5P. Then the P at this point multiply everything on the second parenthesis. So now we're going to move on to the negative 5. So this is going to be negative 5 times P. That's going to be negative 5P. And then negative 5 times negative 5, positive 25. Okay? So now, what's going to be my final answer? The p to the second power, nothing happens to it. But when I take a look at the p's, I have like terms. Same variable, same exponent. So I'm going to be able to add them together. That'll be negative 5 and negative 5, negative 10 p. And then at last, we're going to have our positive 25. At this point, there's no like terms. We're done multiplying. This is my final answer.